Welcome to 3.4. We've arrived page 7. If you notice, page 7, page 6, just more of the same. And this is the first year, this is the first time I've done videos and done as many examples as I have, just because we're kind of in an e-learning environment when I'm doing this. Who knows, I might carry this forward if the results are quite a bit better. Generally, I just do like 3 or 4 examples and say, have at it, and just give you a whole lot of problems. So hopefully that pays off. So here we've got plain old logarithm equals plain old number. Plain old logarithm equals plain old number. Definition log. This is the exponent that turns e into square root of x minus 8. But this is 5. So 5 is the exponent that turns e into square root of x minus 8. And now we've got some challenges. I've got to square both sides, and that presents some problems. When we're solving an equation and we're squaring both sides, it can present problems. The reason is 5 does not equal negative 5. But what happens when I square both sides? They do turn out to be equal. So you can create a false answer by squaring both sides. However, we don't have a choice right here. Therefore, we're going to need to check our answer. So I square both sides and I get e to the 10th. That's 2 groups of 5 e's, 10 e's, equals x minus 8. X equals e to the 10th minus or plus 8. And e to the 10th plus 8 is actually an okay value to put in here. E to the 10th plus 8 is going to work for us. So that's an exact answer, but let's just take a look at that and check it clear because of that problem that we're squaring both sides. So I'm going to go ln second square root x is e to the 10th plus 8 minus 8. Okay, so that's just e to the 10th. The 8's cancel, and we get 5. We see that it's correct. Just barely see. Okay, so that is a good solution right there. But we're around those, so let's see. Second, that's going to be pretty big. Second e to the 10th plus 8. We get approximately 22034.466. Plain old log equals plain old number. Definition logarithm. This is the exponent that turns e into x minus 4 to the second. But this is 5. Therefore, 5 is the exponent that turns e into x minus 4 squared. So we get, I need to take the square root that wants to be plus or minus. X minus 4 equals plus or minus square root of e to the 5th. So that is x equals plus or minus square root e to the 5th plus 4. Let's take a look and see if that creates any problems for us. So we get second square root e to the 5th plus 4. So I get x equals approximately 16.182. And how about negative second square root x to the, where am I here? Sorry. E to the 5th plus 4, enter. It wants to be negative 8.182. And so here's our challenge with this one. Even though those don't violate domains, oh, I didn't square both sides. Those don't violate domains. I can actually have a negative in here. And take a look. If I put in about negative 8, I get about negative 12. If I put in 16, I get about positive 12. But when we square it, we're okay. Those are good solutions. Okay, 110. Now, I don't have plain old log equals plain old number. I've got logarithm plus a logarithm equals plain old number. I refer to this as sum log terms. When you have sum log terms, you want to group them on one side, smash them together, and then use definition of log. So if I smash these together, I get log base 3. This is property 1 of our logarithms. When we have a sum, it becomes a product inside the log. That's x times x minus 8 equals 2. And now I can definition log. Smash them together, definition log. Oh, I know what definition log is. A logarithm is the exponent that turns its base into its argument. Can you apply it? This is the exponent that turns 3 into x times x minus 8. But this is 2. So 2 is the exponent that turns 3 into x times x minus 8. Now we got some algebra here. That's 9 is x squared minus 8x. That's x squared minus 8x minus 9 equals 0. That's x minus 9 times x plus 1 factored equals 0. And x wants to be 9 or negative 1. I'm not saying it can't happen. You can have two solutions on logarithms, but when you do, you should be leery. And probably what we should have done is we should have said, wait a minute, x needs to be bigger than 0 here. X needs to be bigger than 8 here. And the only thing that satisfies that is this. Negative 1 actually causes problems here and here. False answer. You get two answers in a logarithm problem, you better check it. In fact, you probably ought to check domain of your answers. If I put 9 in, I get positive. If I put 9 in, I get positive. I'm feeling pretty good. Okay, so contrast 110 to 112. Some log terms. So I have log term, not a log term. I want my log terms on one side together, my not a log term on the other. Smash, definition log. But watch this, all log terms, you don't have to bring these all to one side. If every term on both sides is log, smash them, smash them. So this is ln x plus 1 on x minus 2 with property 2 from our logarithm properties equals ln x. But logarithms are 1 to 1, so we can drop the logarithm. X plus 1 on x minus 2 equals x. Cross multiply. X plus 1 equals x squared minus 2x. Multiply both sides by x minus 2 is what we're really doing. Let's see, that's 0 equals, this is x squared minus 3x minus 1, not factorable. Oh, yuck. But can we solve that? We can solve it with quadratic formula. I believe there are solutions to this thing. So we get x equals the opposite of b, 3 plus or minus square root b squared 9 minus 4 times 1 times negative 1 plus 4 all on 2a2. That is x equals 3 plus or minus square root of 13 on 2. Let's see. X has to be at least negative 1 x has to be at least 2, x has to be at least 0, x has to be at least 2. Well, 3, let's see, square root of 13 is a little more than 3. So that's 3 plus a little more than 3, a little more than 6 divided by 2. A little more than 6 divided by 2 is a little more than 3. That one's okay. So 3 plus square root of 13 on 2 is okay. But 3 minus a little more than 3 is a little less than 0. And a little less than 0 divided by 2 is a little less than 0. And I can't have a little less than 0 here. That is the only solution. Got to be careful. Okay. So all log terms, smash them left, smash them right, drop the logs. Some log terms, group them on one side, they are, smash them together, I will. Log base 10 of 4x on 12 plus square root of x equals 2. Going to be ugly here for a little bit before we clean it up. Definition log here, this big nasty thing is the exponent that turns 10 into 4x on 12 plus square root of x. But this big nasty thing is 2. So 2 is the exponent that turns 10 into 4x on 12 plus square root of x. And this is just a filthy little problem here. Sorry about that. We're back in play here. So I get 100. I'm going to multiply both sides by 12 plus square root of x. So I get 100 times 12 plus square root of x equals 4x. This is why it's honors pre-calculus. 1200 plus 100 square root of x equals 4x. And what are our eyes drawn to? What's the biggest troublemaker of all? Is this 100 square root of x term. 100 square root of x equals 4x minus 1200. And here's what I'm setting up to do here. I'm going to divide both sides by 4 because it's convenient. 25 square root of x equals x minus 300. What's the biggest troublemaker? That's square root. Yuck. Not happy about this. I'm going to square both sides. That's 625x equals FOIL x squared minus 300 minus 300 minus 600x plus 300 times 300. That's 3 times 3, 9, and 4 zeros. So I get 0 equals x squared subtract minus 1225x, subtract 625, plus 90,000. Guess what I'm going to do next? Maybe it factors. If not, quadratic formula. I'm going to give this a shot, and I totally recommend this. Let's go ahead and graph that thing and see what we've got. Maybe that'll reveal some nice factors for us. I'm not very optimistic. So let's see. We've got x squared minus 1225x plus 90,000. I don't think we might not even have solutions here. Let's go. Boy, I'm going to try this in Zoom Standard, but that's really a long shot. Let's go ahead and graph this. I don't think so. I'm going to Zoom fit this. And we see y equals, did I actually have a parabola here? I did. This should be a parabola, but it's not showing like a parabola at all. So let's go back to our graph, take a look at that. I need to I need to go a lot further. If I go trace here, my values are really, really, really big. So I'm going to let my window go all the way to, let's go to 200, and I'm going to zoom fit again. Oh, we're starting to see some curve there. But if I trace this thing, we're still way above 0. So let's see what happens. I'm going to go window. I'm going to go to 1000. Zoom 0. Zoom fit. Oh wow, 1000 got us to bottom out here. Let's go second calc minimum. Let's see what the minimum is between here and there. You see the minimum value for y is, or for x 612, but the y value, it never gets down to 0. The y's never get down to 0. That means this thing is a parabola that is entirely above 0. It never gets down to 0. Therefore, this thing can't equal 0. No solution. So a little bit of a payoff. We would find that out when we went to quadratic formula with it. If we went x equals opposite of b, 1225 plus or minus square root 1225 squared minus 4 times a times c minus 4 times 1 times, 90,000. Look at that. That times 90,000, that's pretty big, times 4. Yeah, 1215 is going to be big, but I think that 90,000 must, at times 4, must ultimately outweigh it. So we got a real break there with no solution. So not certain that that happens for you on 13. Try to battle through. I will tell you that one, you get that one correct. Go through the work. You should feel like an honors pre-calculus student for certain. The rest, quite a bit more straightforward, but I thought I'd throw one in there at the end that might stretch us a little bit as we should be stretched. So that is the end of a big section 3.4. Hopefully you're in great shape on it, but if not, ball's in your court to ask questions.